Some properties of gases. Almost all gases are colorless, that is, invisible. We're sitting in a mixture of them now. Yes, air, which is a mixture of oxygen and nitrogen. Hydrogen and carbon dioxide are also colorless. One exception is chlorine, which is a pale green color. It's also poisonous. So it's not easy to examine gases because you can't see them. But some have odors, like the foul odor that comes from rotten eggs, or the pleasant odor that comes from microwaved popcorn. There are also pleasant odors like that from perfume, which I'm going to use here to illustrate the first two properties. Now, suppose we place a bottle of perfume at the front of a classroom, and then open the bottle. We'll see that the first students to smell a perfume will be at the front, but eventually everyone in the class will smell it as it spreads out. At first, when the gas was inside the bottle, it took the shape of the bottle that was above the liquid, but then it ended up filling the whole classroom and taking the shape of the classroom. This illustrates the first property of gases. They have an indefinite shape. That is, they take the same shape of the container that they're in. Secondly, let's consider volume. At first, the volume is small, occupying only that space in the bottle above the liquid. But then it ends up filling the whole room. So that means that the volume is also indefinite. That is, it fills the container that it's in. For the next property, have a look at this short clip. Carbon dioxide gas is being produced in a bottle using baking soda and vinegar. There are 5 lit candles. From your observations, see if you can figure out 3 physical properties and 1 chemical property. So, did you notice that carbon dioxide was colorless, that is, invisible, and also that it appeared to be poured out of the bottle, and that because it must have flowed downward to reach the flames, it is denser than air. So the 3 physical properties are colorless, fluid, that is, can be poured, and more dense than air. The chemical property is that carbon dioxide does not support combustion since it snuffed out the candles. That is, things cannot burn in carbon dioxide. The property I want to focus on here is that all gases, like carbon dioxide, are fluid. They can flow. Here's a second example of a gas that is colored and is often shown by teachers in high school laboratories. It's called nitrogen dioxide. It's being poured out of the flask and into the beaker, which means that it is fluid and also that it is denser than air. Let's look at the next property. We'll take a metal can containing a gas that could be air or any other gas, and then introduce a piston which can move up and down. When we push the piston down, you can see how much the gas is being compressed. It won't go down all the way because gas is made of molecules, and you can't squeeze molecules down to nothing because molecules are matter. Nevertheless, we see that gases are very compressible, which is our 4th point. Gases are very compressible. An application of this property is the propane tank used with barbecues. Since propane is a gas, a lot of it can be compressed into the tank, which means the tank can be used for weeks or even months. Now, saying that the gas is compressible also means it's expandable, just like the perfume expanded into the classroom. Here is a helium balloon ready for release. Notice the wrinkles, which indicate that the balloon is not fully inflated. When it is released, the balloon rises, and the air pressure around it gets less and less, just as the air pressure going up a mountain becomes less and less. This allows the helium inside to expand more and more until the balloon becomes fully inflated. Here's one being released. It gets fully inflated at maximum height. Now, for the final property, let's examine the effect of heat on the volume of a gas. Watch this clip. This demonstration will show how heat has a large effect on the volume of a gas. This pop bottle has air inside it capped by this yellow balloon. This is hot water, and this is cooler water taken from the tap. I'll put it in the hot water first. Why is the balloon getting larger? Because the heat from the water is causing the air in the bottle to expand. The air also expands into the balloon, causing it to get larger. Now, it's not going to expand the way it would if you blew into it, because that requires a lot more pressure. Now I'll put it into the colder water. Why is it collapsing? Because the warm air in the bottle is losing heat to the cold water. This causes the air inside the bottle to contract, so there is air leaving the balloon, causing it to collapse. This shows that gases are very sensitive to changes in temperature. This shows a fifth property of gases. They expand greatly when heated. Now, on a much larger scale, here is a hot air balloon. The heat from burning propane causes the air inside the balloon to expand greatly, thus making the whole balloon less dense than air, which causes it to rise when released. Here's a short clip of heating air in action. As a final note, let me repeat that gases are much more sensitive to heat and cold than solids or liquids. There are many more properties of gases, but these 5 are good ones to know. This ends the video on some properties of gases.